Welcome back to Trig Notes 2.4, Pre-Calc Notes 5.4. This is going to be part 2 of the video. We're going to continue using the sum and difference formulas for sine, cosine, and tangent. As we look at this next example, we're going to actually work backwards. We're going to be given this portion of the formula, the sine of some angle times the cosine of some angle plus cosine of some angle times the sine of some angle. So we're given this portion with the plus sign, so that means we're going to use the top one. And we're going to have to figure out this portion of it. So I know my answer is going to be the sine of u, and since I use the plus sign, the top sign, I have to use the plus sign. So that's going to be my answer. I just have to figure out what u and v are. So as I look at this portion in red, which is what I'm given, it was uv and then uv. So here I have the sine of 140 plus 50. My answer would be the sine of 190. So again, here I'm just working backwards to simplify something down where I can't find exact values of these angles because 140 and 50 are not on the unit circle. So if I'm just simplifying it, not finding the exact value of this answer, because my instructions say simplify, it's just going to be the sine of 190. Here's another verify problem where I want to show that the left side, so this cosine of the difference of these two angles plus the sine of the sum of these two angles equals 0. So I'm going to have to use the sine and the cosine formulas over here for the sum and difference. So as I look at the cosine one, my u value will be pi and my v value will be theta. So if I plug it into this, it's going to be the cosine of u, which is pi, cosine of theta. Then it's a minus there, so minus is the bottom sign, so I use a plus. The sine of pi, cosine of, sine again, sine of theta. We'll go back and we'll simplify this in a minute. Now to that I need to add the sine of two angles that are being added together, so the sum. So this would be u and this would be v, and I'm going to use this formula now. So to that I will add the sine of u, cosine of v, and then there's a plus here, so the plus is the top sign, so I use the plus because that's the formula. Cosine of pi over 2, sine of theta. And again, I'm going to go to my unit circle and I'm going to pull this information off of there. So on the unit circle, the cosine of pi is -1, so I get negative cosine of theta, plus the sine of pi is 0, sine of theta. So I can actually simplify this all down to just a negative cosine of theta. Okay, bring down your plus sign. Over here, the sine of pi over 2, again from the unit circle, is 1, so I get 1 cosine of theta, and plus the cosine of pi over 2 is 0, again from the unit circle. So really, again, when I add these two together, that's not there, it's 1 cosine of theta. Negative cosine of theta plus positive cosine of theta cancel each other out, I get 0. Remember, that's what I was trying to get it to be equal to, so I was able to verify that all of this, by using two sum or difference formulas, reduced down to 0. And again, when you look at this, kind of break it up into two separate parts. You're using the formula two separate times here, and I tried to specifically do the cosine portion in blue and the sine portion just in red, so you can see that that's where I was getting those from, was using the formulas over here twice. Now our last example is actually asking us to solve for x. So that means we are going to want to find out which x values work for these specific angles. And notice that it wants me to give my answer one time around the unit circle in radians. So make sure you pay attention to your domain to know that it should be in radians. So what I'm noticing here is I have the sum of the sine and I have the difference of the sine. So I'm going to use this formula twice, where the first time I use it, x is going to be the u, and pi over 3 is going to be the v, and I'm going to plug it into the plus. So it's going to be sine of x cosine of pi over 3. and then because it's the plus, it's a top sign, so it's plus cosine of x sine of pi over 3. Now the second time that I use it, I'm going to be using the difference formula where, again, my x is going to be the u and my pi over 3 is going to be the v. And I'm using the minus formula, so I use the minus here. So it would be sine of x cosine of pi over 3 minus then cosine of x sine of pi over 3. Again, I'm using the formula twice. I tried to use two different colors to show you the two different spots where I used the formula. And this whole thing should simplify, or should be equal to 1. So I'm going to try to simplify all of this and then solve. So the difference is I'm solving, not verifying. Alright, let's go to the unit circle. Now I'm going to do this part first. I'm going to do the cosine of pi over 3. Cosine of pi over 3 is half. So it's going to be half times the sine of x. Then I'm going to do this portion first, so it's going to be plus. Sine of pi over 3 is square root of 3 over 2, and then cosine of x. Okay, bring down the plus sign. Again, do this part first. Cosine of pi over 3 we already said was 1/2. Bring down your minus sign. Do this part next. Sine of pi over 3 was square root of 3 over 2, and then bring down the cosine of x. So what I'm noticing is I've got a couple different sets of like terms. I've got some sine of x's, and then I've got some cosines of x's. Half plus half makes 1, so this is 1 sine of x. Square root of 3 cosine of x minus square root of 3 cosine of x will actually cancel each other out. And so now this whole thing equals 1. So if I divide by 1 and move the sign over by taking the inverse, what it's really wanting me to find is look at your unit circle and give me all of the angles that have a sine of 1 in radians one time around the unit circle. So if I go up to my unit circle, I'm finding that the only angle that has a sine of 1 is pi over 2. I'm going to want to take the time to verify that, and I can verify that by typing this all into my calculator. Make sure your calculator is in radian modes. You should be able to do the sine of pi over 2 plus pi over 3 plus the sine of pi over 2 minus pi over 3, and it should end up reducing down to 1. And we can see that, again, if our calculator is in the correct mode, when I type that in, I do get it to reduce down to 1, so I know that 1 equals 1, and therefore this checks out. I don't have to go through and list multiple coterminal angles because of the fact that my domain here just asks for one time round and in radians.